Law of universal gravitation practice worksheet. Like any problem, let's do the problem solving process. We've got every number, 15.0 kg, write it down. 2.00 kg, write it down. 1.50 meters. Writing down all of the numerical values with their measurements. So we have a 15 kilogram bowling ball and a 2 kilogram rock floating in outer space, 1.50 meters apart. What is the force of gravity between them? Okay. Kilograms measures mass. Kilograms measures mass. Meters measures distance. So if you notice, bowling ball and rock, we've got two different objects. I'm going to label the bowling ball object 1 and the rock object 2. So mass 1 is 15 kilograms, mass 2 is 2 kilograms. It doesn't really matter which object is number 1, which is 2. Doesn't make a difference. The distance is the distance that separates those two objects. All right? Now if we want force of gravity, we have Fg is equal to gravitational constant multiplied by the mass of object 1 times the mass of object 2 divided by the distance between them squared. That's our formula. Let's plug in the values. Okay? Fg is equal to 6.67 times 10 to the negative 11. Okay? Mass of object 1, 15.0 kilograms, multiplied by the mass of object 2, 2.00 kilograms, divided by the distance between them, 1.50 squared. Okay? Now, I need to emphasize, you need to multiply that 15 times 2 before you divide. Okay? You must multiply that 15 times 2, and then you'll divide it by the 1.5 squared, and then that will be multiplied to the 6.67 times 10 to the negative 11. Now, to be successful, you need to be able to do this on a calculator. So, let's first try putting that number, the universal constant, gravitational constant, into the calculator. Okay? So everybody type in 6.67. Type it into your calculator. Everybody, calculators, 6.67. Now, hit the second button, yellow or blue. The button below it that says log, if you look up above it, it says 10 to the x. And you hit that, that's the same as that times 10 to the. Okay? And now put in, you see it started parentheses there, negative 11, and close those parentheses.
Would it still work if we did like times 10?
You can, it just, this is a shorter, faster way to do it. Okay? Now, we're taking that 6.67 times 10 to the negative 11. Now I want you to hit enter. 6.67 times 10 to the negative 11. You see that little times 10 there at the bottom? This is what it looks like, scientific notation, your calculator. Okay? Everybody sees that? Everyone can do this. Awesome. All right, now, to put this in your calculator, you can put it all into your calculator all at once, if you are careful with the parentheses. Okay? So, when you put in the calculator 6.67, all right, like it shows here, that little 10, that's called a caret. Don't ask me why, but it is. Parentheses, negative 11, close the parentheses. Okay? Now that represents just that right there. Now we need to multiply it to all of that. So a little multiplication symbol, a little star thing. Okay? And here you have to put in 2 parentheses. And this is what we need the colors for. That big outer parentheses is the first one you just put in the calculator. The smaller inner parentheses That's the second one you just put in the calculator. Okay? And then put 15.0 and then multiply symbol 2.00. Now you need to close parentheses. That closing parentheses is the parentheses after the 2.00 in the formula. Okay? And then divided by 1.50 and then the squared. Close parentheses. That's that final parentheses, big, large parentheses in the formula above. Okay? So, go ahead and type that in the calculator and see if you can do it. Okay? 6.67 times 10 to the negative 11 multiplied by, then double left parentheses, 15.0 multiplied by 2.00, close parentheses, divide 1.50 squared. Now the squared, guys, it's a button next to the 7 that says X with the 2. That's the squared button. And it gives you the squared just like that. And then close parentheses and enter. And the calculator says 8.89 times 10 to the negative 10. Okay? So, significant figures, 3 significant figures in all my starting numbers, so 3 significant figures is my answer. I'm going to put 8.89 times 10 to the negative 10.
What's your answer?
That's the answer. What am I missing? My units. What was I solving for? Force. Force in newtons. Now, look at this for a second. 8.89 times 10 to the negative 10. What does that negative 10 tell us about this number?
Small.
It's really, really small. So if you have a very large bowling ball and a large rock floating in outer space, even if they're only 1.5 meters apart, 1.5 meters apart, like the length, the height of a person, a shorter person. All right? That distance, it is still such a weak force, it's barely noticeable. Okay? Does that kind of make sense?
Yes.
Because they're such small objects. Their masses are so small. Okay? So this really is about, like, comparing planets. All right. Next one. The reason why I don't do the planets is because of the math. It's a lot easier to put in the calculator. We're not doing that so big of a thing. We'll get to that one on number 4. But for now, keeping it easy still, number 2, give it a try. All on your own. Write down what you know. Write down your variables. That's going to be your formula. Plug them in and see if you can get an answer.